outside the shell, and this was listening to port 8080. So I think the most useful, useful for an attacker way to use a local privilege escalation exploit for Windows is obviously to combine it with another remote exploit or semi-remote exploit, like a client bug or a bug in Office XP, or just to prepend it to the installer of their Trojan or something. So I think even though it's a local bug, it is quite dangerous. Well, anyway, now over to the next speaker. So, Christer.
I'm going to talk about a NetBSD kernel vulnerability. It's a vulnerability that is currently an ODA. It is very similar to another vulnerability I presented in Amsterdam. I found the vulnerability by using our fuzzing tool developed by my colleague Klaus. What I did was to write a script that generated sockets using random combinations of domain types and protocols, and then attempted to bind them with a random socket address. And this led to an almost instant crash, and I began tracking the vulnerability down, and it was simple to do because I was familiar with the code, and I've already exploited a very similar vulnerability. The debugger I used is called DDB. It's the default kernel debugger on BSD. The kernel can also be used, you can also use GDB to debug the kernel, either by analyzing a crash dump file or setting up a serial connection between two machines and do live debugging. I've prepared a little demonstration showing off DDB. So here we have a user logged onto the machine, and he's left his workstation and locked the console. And I can't find the key, so I use a keyboard combination to break into the debugger. And I'm going to kill the process. And now I need to reset the terminal. And I'm just a normal user. So I'm going to write a little exploit exploit to get root access using the kernel debugger. So I entered debugger again to set a breakpoint. Run the program and the breakpoint hits. And I'm setting another breakpoint. This suser function is basically just returning 0 if it's a root user calling. And of course, if root is trying to do a set user ID, the system is going to allow it. So now I'm going to change the return value. So I change the return value of that function. And now I've got a root shell. So root shell. So the vulnerability I'm going to talk about is a straightforward buffer overflow. It's a call to B copy with a user-supplied length argument, and an mbuff pointer is overwritten and then subsequently freed and exploited. And an mbuff is basically as a kernel memory unit, and it's used throughout the networking code for things like socket buffers and packet data. And the mbuffs are arranged in a linked list, a doubly linked list. I've exploited mbuffs in two different ways on NetBSD. The first technique I've used was a simple unlink technique, very, very similar to exploiting malloc and free bugs. The second technique uses a very, very hacker-friendly feature where you have a function pointer in the actual mbuff header to a function it wants to be freed by. So you can just take this function pointer and point it to your payload, and when free is called on this mbuff, your payload will be executed. And this is the function that is eventually going to free our mbuff, and all I want to show is that I end up in a while loop when we're freeing this mbuff. And instead of breaking out of this while loop using the conditional statement, I'm going to do it in a slightly different way. So first, about the unlink technique, like I said, exploitation is based around unlinking an mbuff from this doubly linked list. And this is the macro that performs that unlinking. And what is basically happening here is two memory operations. And I'm going to illustrate it with an example. So say your next ref pointer is pointing to address deadbeef, and your previous reference pointer is pointing to bad coded, then the memory operations can be described with the two C statements here. So deadbeef is written to address of bad coded plus an offset, and the other way around. So we can write to an arbitrary kernel memory address if we control these two pointers. And we have a few options how to take control of the kernel using this override. We can override the return address on the stack. The problem with that is we don't know exactly where on the stack the return pointer is or at what address it will be. Also, we need the return value to return to whoever called us in the first place. Another option is to take a function pointer from an IOCTL, for example, and just override the function pointer to point to your payload, and then execute IOCTL to execute the payload for you. The problem with that is we don't necessarily know the original value that we're overwriting, the value of that function pointer. And we really, really need to restore it, because if somebody else calls that IOCTL after us, they're going to crash the kernel. So what I do in my exploit, I use a symbol called sysint, which is basically as an array of function pointers to the functions implementing the system calls. And I take an unused system call number and then take that function pointer, point it to my payload, execute the payload by executing the system call. And since I'm overwriting a known value, this function pointer I'm using, I can easily restore it. When you're using this technique, the mbuff that you're freeing is going to be put back into a memory pool. The problem with this is it doesn't really belong there and will crash the kernel unless you clean it up. And the code behind the scenes is not very easy to read and understand, and it changes from release to release. But there is a very easy workaround. You can just call a function to reinitialize the entire thing, and that takes care of the problem. The second technique, and the technique I'm actually using in this exploit I'm going to show, is using this function pointer. And to exploit this, we're going down the same execution path, but I want to avoid unlinking from taking place, and the way to do that is to take the next ref pointer and point it to the mbuff we're freeing, and then just take this function pointer for the free function and point it to the payload, and the payload is executed on free. And when you're using this technique, no attempt is ever made to put the mbuff back into the memory pool, so there is nothing to clean up, which is very nice. So my payload is very simple. All I need to do is elevate my process privileges to root. To do this, I need to find my process, my process proc pointer. There are a few ways you can do that. The best way to do it is probably to use the FS register. And by using that, you can get a pointer to an LWP structure, which contains a reference to your proc structure. When you have your proc structure, you can find your process credentials quite easily, and then all you have to do is modify them and change your user ID to 0. To break out of that while loop I showed you, I'm just executing an extra leave instruction from my payload, and which will take me to a stack frame higher up. And since the kernel can reference user space memory, I don't have to copy the payload into the kernel. I can just simply return to a user space address. So okay. So now I've got root access. And I'm using actually a patched kernel, so I'm not cheating and using my old NetBSD exploit. This is a new exploit. Hur får jag fram presentationen? I'm not very good at Windows, but something tells me that if you can get an EIP that you control remotely, something is really wrong. And that's Klaus' turn to talk.